Hello students, welcome back to OrganiChemVerse. Today I'm going to solve a question based on alcohols and phenols. What is the question? That there is an alcohol when treated with an acid under heating condition forms product. The same product can also be obtained from phenol when it is treated with zinc test. Then what could be the structure of the alcohol? This question can have one answer or more than one right answer. So let's analyze the options. See, when phenol is treated with zinc, we know that it's undergoing reduction. So zinc will go with the oxygen as zinc oxide and the product formed is benzene. So we are supposed to get the product as benzene. When we analyze the options, it's quite easy that we can eliminate option C. Why so? Because there are 7 carbons here and there are only 6 carbons in the product. So you can eliminate this. And also look at this. There is only one alcohol. So upon dehydration, max to max, you can have 2 double bonds. So we are supposed to have 3 double bonds. Therefore, you can eliminate this option as well. So analyze for A and B properly. So how do you do that? We have to write down the sequence of reactions. That is there any possibility of this reactant converting to the benzene? So let's do that. See, this is an alcohol with 2 double bonds, right? So when it is treated with H2SO4, heating condition, that means what? It is a dehydration. But the dehydration will not happen in one step. Why so? The first step is the protonation on this OH and then removal of water, that is dehydration, right? And then it's going to form a carbocation like this, CH2 plus. The formed carbocation is a primary carbocation. It's not so stable. So what you can expect is ring expansion. What is ring expansion? Whenever a 4-membered ring converts to 5, or 5-membered ring converts to 6-membered, we call this as ring expansion, and it happens so because of the stability of the molecules. Here, this 5-membered ring can undergo expansion so that it will become 6-membered ring. Then it will be stable. So that is the driving force for the given molecule to undergo ring expansion. Many students will fail to understand ring expansion. So let me explain this in detail. Look at this. This is carbocation. This carbocation receives these bonding electrons. It has to break the bond either here or here, and then it will give its electron to this CH2. So how to write the product? Observe carefully. Here it breaks and forming bond here means it's going to be a 6-membered. So write that as it is. And this double bond, it is not changed, untouched, right? So you write down that as it is. This is a carbon attached to 2, right? So a double bond carbon attached to this carbon, right? So I'm marking these 2 carbon. Earlier it had 4 bonds around it. How so? 1, 2, 3, and then there is a hydrogen like this. But because these electrons are given to CH2, it is deficit of the electrons. Therefore, the carbocation will move here. And it is attached to CH2. So, write down like this. Right? It is attached to CH2. Now, what happens? This is secondary carbocation, which is quite stable as compared to primary. That is a driving force. And also, we have to regenerate whatever the protonation happened in the first step, right? So, remove the proton. So, then what you are going to get? You're going to get benzene, which is as shown in the question here. That is the product. Therefore, the answer is A, right? What did we do here? From a non-aromatic to aromatic molecule. So that is also the driving force for the ring opening and expansion of the ring. And let's check for option B. This is quite simple. Look at this. There are 2 double bonds and then there is a hydroxyl. This is very susceptible to undergo dehydration. Why so? Because when it undergo dehydration, the double bond formed can undergo resonance with the other two double bonds, right? So that means what? It is nothing but aromatic. So that is a driving force. That's why it will undergo dehydration easily in presence of a dehydrating agent like H2SO4. Therefore, the alcohol given in option B also undergo dehydration to form product that is benzene. Hence, option A and B are correct. Thank you for watching this video, and if you still have any doubts with respect to this, you can always comment them in the comment box.